Alright, so... Oh, there we go. Alright, so I erased some of the... Ooh, I don't want to do that. I don't want to do that. So I erased most of the stuff. Let's get this thing back. Ooh, that's a good hand spot. I can work with this. We have A. Coming over the edge. We have B. And their weights. Let's look at a free body diagram. I'll put that up here. To the right, we have tension. To the up, we have the normal force, which we know is going to be Fg cosine theta, because the gravitational component, is Fg cosine theta. And then we're going to have two forces to the left. I'll put one on top and one on bottom. We have the gravitational component that's pulling it down, right, is mg sine, or Fg sine theta. And then we also have the friction force, which is mu F n. Alright, so let's look at Newton's law. Sum of forces in the x. I had it. I thought I had it. I don't. We get Ft. Oh, you're right. This is the force of friction. I don't know why I changed everything else. Ft minus Fg sine theta minus the force of friction is equal to ma. Okay. So let's see where he took you. A lot of this is weird. I feel like some of this is weird. Whatever. So we know that the force of tension is going to be equal to the weight of the block. We talked about that last time. So 32 minus Fg sine theta is 102 times sine of 40. And friction is going to be coefficient of kinetic friction times the weight of A times you have sine of theta written. I think it's cosine. Oh, I just redid this whole problem because I got a different answer. I would double check. I think if this is what he had on the board, I think this is a typo. You have mu k, which is, here's what friction is. It's mu k times Fg cosine theta, right? Because friction's mu times the normal force, and the normal force is cosine theta. You have sine written here. But I'm gonna go through this anyway. And this is mass A, right? But this would be 0.25 times 102 times cosine of theta. Maybe we'll get the right answer. I don't know. 32. And I should have left these up. Oh, I should have left my calculator up. Right. Let's make this guy a little bit smaller if I can. Nope, I can't. Alright. So 40 sine times 102 equals 65.56. Let's plug that whole guy in. 40 cosine times 102 times 0.25 gives us 19.53. 0.53, and that's going to be equal to the weight of A divided by gravity. So 102 divided by 9.8. What? That's stupid. 102 divided by 9.8. That makes more sense. 10.4. What am I doing? Oh, yeah, duh. 102 divided by 9. Oh, you just texted me. Divided by 9.8 is 10.4. 1 times acceleration. So we get 32 minus 65.56 minus 19.53 divided by 10.41 gives us an acceleration of negative 5.1. Oh yeah, that's 0.1. Works for me. Meters per second squared. But I really think your professor made a mistake, and if he did, if you have time before the test, I would talk to him and see if that was a mistake or not, or if you filled that out on your own and just took it from there. But that part where I talked about the sign. All right.